Good afternoon, class. You can sit down, thank you. All right, in our previous lesson, we looked at variation, direct variation to be specific. We will be looking at inverse variation today. You were given an exercise to do from, I think, question 1 through to question 10. Am I right? Okay, there are 9 questions. You would have noticed that question 5 was the same as question 6, but I'm going to give you a different question based on question 5 today. All right, we did questions 1A and B. We'll be doing the questions from 1C up to question 10. All right, this time we'll start from the front. Taumaku, you have the honor of giving us the answer to 1C.
The answer is 75.
The answer is 75? Okay. Kyle, D?
N equals 28.
N equals?
28.
28. Let's see. Okay, yeah, N is equal to 28. 2A? The mass of an object varies directly with its volume, right? The formula connecting M for mass and V for volume.
M equals K times V.
Okay, M equals K times V. Next one, B?
The value of constant equals 2.5.
2.5 is correct. Okay, that's question 2. We did question 4 as an example. So now we go on to question 2C is still to be done. Okay, yeah, question 2C. Livingston, your turn.
M equals 40
40 what?
grams.
Grams, okay. 40 grams. Right, number 3, given that y varies as x, complete the following table. Patrick, you have to give us the value for y when x is 4.
When x is 4, y equals 2.8. When x is 6, y is 4.2. When x is 15, y is 10.5.
Okay. 2.8, 4.2, and 10.5. You all got that? Okay. That was supposed to be question 5. In 30 meters, a bicycle wheel revolves 13 times. How many meters will the wheel travel in 100 revolutions? Okay, we'll do this after we complete the homework. All right, we'll look at question 6. Miriam, your answer for part A.
32.5 miles.
32.5 miles, let's check. Okay, correct. Next one, letter B.
60.8 kilometers.
Let's see. Okay, 60.8 kilometers. That was for 6A and B. Next one, number 7. Chutaili.
229 kilometers.
Is it 29 or 92? 29? 228? Okay, what does it say? A faulty odometer records 154 kilometers for a journey of 137 kilometers. If it shows 256 kilometers for a journey, what is the true distance to the nearest kilometer? Let's see what my answer is. Okay, can anyone detect a mistake? Hey, Koi, can you detect a mistake on the answer on the monitor? Okay, this one should be 137. Okay, so it should be 154 over 137 multiplied by 256. Okay, I've heard two answers. Some people are saying 228 and others are saying 229. Why are there two answers? Okay, if it's 154 over 137 times 256. This is the final step that I put down. Okay, what is the actual answer that we get? 200, Hekoi? 200 and?
287.7.
287.7. I thought Chutali gave 229. You gave 229. Okay, it should be 287.7, which is 288. Or is it 28? But why is this 287.7? Huh? Why 137 over 154? Okay, a faulty odometer records 154 for a journey of 137. If it shows 256 kilometers for a journey, what is the true distance to the nearest kilometer? Then the answer should be more than... The answer should be more than 137, am I right? Okay, let's see. Okay, we are given distance. Okay, distance of a journey, I'll call it J, varies. Okay, a faulty odometer records 154 kilometers for a journey of 37. Okay, this is the journey one, and this would be the distance that the odometer records. Okay. So J is equal to K multiplied by D. All right, you are told that this is 137. Am I right? Okay, equals K times 154. So it's K equals 137 over 154. Okay, so J equals K multiplied by 137 over 154. Sorry, 137 over 154 multiplied by D. Okay, so it's 137 over 154 multiplied by the distance is 256. Okay, then the answer is going to be 220 exactly. 227.7. Okay, you win, which is equal to 228 kilometers. Okay, take note. Those of you like me who made a mistake. That's question 7. 228 kilometers. All right, next question, question 6. Question 8. Velma, your turn.
7 centimeters.
Which is that to the nearest whole number? Okay. I think I've got it as 6.9 to 1 decimal place. Okay, you can have it as 6.22 decimal places. 86 to 2 decimal places. Okay, 6.9 to 1 decimal place, 7 to the nearest whole number. But what I would like you to do is to state it. If it's to the nearest whole number, then say 7 centimeters to the nearest whole number. Okay, next one, 8B. Vui,
12 kilograms to the nearest kilogram.
12.
Kilograms to the nearest whole number.
Did you all hear it? Because he's talking to himself. Talk to everybody.
12 kilograms to the nearest whole number.
Okay, 12 kilograms. Or is it 12 grams? Okay, 12 kilograms. I put grams. Okay, 12 kilograms, not grams, because the measurement is in kilograms. Number 9, Solomon.
The constant is 4.9.
The
4.9.
constant is
4.9.
4.9. Very good. Okay, next one. B, how far would the object fall in 6 seconds?
176 meters.
Is that to the nearest whole number?
Yes.
Okay. To the nearest whole number, 176 seconds. No. Meters. Did you put seconds? No, I'm asking Lester. At least I won't feel so bad because I put the wrong units. Okay, it should be 176.4 meters. It's distance, not time. I don't know why I'm getting my units wrong. Okay. Any questions you want me to explain? Any questions? So you are all experts in direct variation? Okay, Kyle has a question. 8A. Okay, that's what I've got. The question says the extension in a spring varies directly as the size of the mesh suspended from its end. So if the extension is E, E varies as the mesh, as the size of the mesh suspended from its end. And E is equal to the constant multiplied by M. You are told that the extension is 2 centimeters when the mesh is 7 kilograms. So K is 2 on 7. Okay, if K is 2 on 7, then the equation is E equals 2 on 7 multiplied by M. Okay, so since the mesh is 24 kilograms, 2 on 7 times 24 will give 6 point whatever it is, to 1 decimal place, 6.9 centimeters. Oh, it's just question 7, no A and B. Okay, I thought I did question 7 on the board. Do you want me to do it again? Okay. You all got this one? I mean, those who did not do this one properly. Okay, question 7. I put J to represent distance that is read from the odometer. So J varies directly as D. Or should it be the other way around? A faulty odometer records 154 kilometers for a journey of 137 kilometers. Should it be the other way around? I think so. I think it should be D varies directly as J. And D is equal to K multiplied by J. D is equal to 154 when J is equal to 137. So K is 154 over 137. It's the other way around. So, where is it? D equals 154 over 137 multiplied by K. So 154 over 137 multiplied by 256. Okay. You look at the answer that we got first and you look at this one and then we just check it with the information. Did some of you get 289? Or all of you got 228? Hekoi, what did you get? 229, 228. A fault odometer records 154 kilometers for a journey of 137. Journey of 137. If it shows 256 kilometers for a journey, what is the true distance to the nearest kilometer? No, now, and it's going to be, the answer is correct, but this one is, D is now, we're looking for D, am I right? 154 over 2 times, sorry, this one's supposed to be J. So 154 over 137 times 256, what do we get? Is it 288? Huh? Check the answer, please. 288. Okay, we'll just look at this answer and the way we did the other one and see which one makes sense. Can we? Okay, it says a faulty odometer records 154 kilometers for a journey of 137 kilometers. Which means if a journey is 256, then the odometer will record higher than 154. If it shows 256 kilometers, so then that one is supposed to be D. Right? Okay. Now we are getting somewhere. We do not know what J is. So I multiply 256 by 137 and I divide the answer by 154. Okay. We are back to where we were, which is, okay, so 228. Okay. Now we are all happy. Is there any other answer before we go on to the other type of variation? No? Okay. I've just written a slightly different definition of direct variation because if you realize what I wrote in the previous lesson, I said when one quantity increases, I just used the word increase, which is not really correct. I should have used the word change. Because like in direct proportion, when one quantity increases, the other increases. When one decreases, the other decreases as well. So it wasn't correct when I said just increase. So please take note of that. Okay, so I've just wrote something that's slightly different that is very much similar to, that you can use to differentiate between direct and inverse variation. So I've got another definition here. It's more or less the same, but I used increase instead of change. Okay, one quantity is said to vary directly if the relationship is such that any change in one produces a proportionate change in the other. I just said increase. When one increases, the other increases. Please remove that from your mind. It should also be when one decreases, the other decreases as well. So that's why here it's better, because it's so long as they decrease or increase in the same ratio. That's what proportionate means. Is that clear? Okay, now inverse proportion or inverse variation is the opposite. It says when one quantity is said to vary inversely as another quantity, one quantity is said to vary inversely as another quantity if one varies directly as the reciprocal, take note, as the reciprocal of the other. So I've just written here, if y is said to vary inversely or indirectly as x, then we are saying y varies directly as the inverse of x. So y varies as 1 over x. Clear? And I wrote down the equation as well. Y equals 1 times x times the constant, 1 over x times the constant k, and y equals k on x. All right, that's inverse variation. I've got two examples here where the quantities vary inversely, and I mentioned one of it when I was talking about inverse proportion. All right, the first one here is given distance, for a given distance, time varies inversely as speed. You all know that. And in physics, I think they say that at constant temperature, the volume of gas varies inversely as pressure. So those are just two examples of situations where the quantities vary inversely. You will probably do a lot more experiments in physics. We don't do much experiments in math, so I can't prove that. Okay, number one example. Given that P varies inversely as V, and P is equal to 8 when V is 14, find P when V is 4. Okay, so P varies inversely as V, so P varies as 1 over V, and P is equal to K over V. And then I substituted P to be 8 and V to be 14, and K is 8 times 14, which is 112. I hope I'm correct in that one. Is that correct? Okay. The equation will now be, when I put in the value for K, P equals 112 over V. And when V is 4, P is equal to 112 over 4, which is 28. Okay, I would like you to use this example to see if you can do example number 2. Are we finished? Okay. The force of attraction F between two bodies is inversely proportional to the square of the distance d between them. If F is 20 when d is 5, we have to find F when d is 10 and d when F is 80. Okay. F varies inversely as the square of d, and F is equal to k over d squared. Now F is 20 when d is 5, so we have to square 5. Right, so k is going to be 25 times 20, which is 500. Okay, the equation is F equals 500 over d squared. That's the equation you have to substitute into to find F when d is 10. Okay, so number 1, when d is 10, it will be 500 over 10 squared, which is 5. Right, so your answer for number 1 should be 5. And your answer for number 2, we have to find F when d is 80. So F, wrong. Find d when F is 80. So 80 equals 500 over d squared. Okay, if you divide 500 by 80, we get 6.25. Okay. And d is equal to the square root of 6.25, which is 2.5. Okay, then your next task is to do question 1, A, B, C, and D. You have to complete that before the bell goes. All right, we'll look at the answers to question 1. Ponrele, can you give us the answer to 1A, please?
P is equal to K divided by V.
Okay, P equals K over V. Gabriel? Your answer for B, please.
K equals to 48.
K equals 48. And Peter, C,
P equals 12.
P equals 12 is correct. And Andrew for letter D,
V is equal to 3.
V equals 3. Okay, but I'm sure you don't have to, divide 48 by 16 and use your calculator. You can use your brains to do that. Okay, your homework is from question 2 to 25. Oh. No, don't worry, 10. And that includes question 5 from the previous lesson as well. It's not plenty. Okay. The keyword to the pilot teacher is inverse. Good afternoon, class.